Okay, I'm gonna do the this worksheet, believe worksheet 4. I'm gonna start with the second question. I'll go back at some point and go over the first one, and I'll tell you why we all thought that it's a little bit ridiculous. Uh, so we'll start with the first question. So the second question. So you have y double prime minus 4y equals et e minus t. So the first step is you find the homogeneous solution. So you know it's like m squared minus 4, and for the homogeneous solution you set it equals 0, then y squared equals 4, and you get m equaling minus 2 or m equaling 2. So two real answers. So your homogeneous solution would be C1 e to the minus 2t and C2 e to the positive 2t. This is how you write the solution when you have two different, like that's what we talked about in the previous worksheet. This is the homogeneous. Now for the non-homogeneous, it's called yp. Now this is where it gets a little bit tricky. First of all, you need to see if the e and the e, if anything repeated, like this is e to the minus 2, you don't have e to the minus 2t, and you don't have e to the the positive 2t. So all you need in this case, you take the first one, there is no t in front of it, it's only a number, so you say constant et. So even if it's like a 2 or a 3 or a 4, as long as it's a constant, you just give it an a. And in front of the e, that's a constant too, so we go b e to the minus t. We're going to compare coefficients. To do so, I need to find the second derivative. So first derivative is itself. This one is minus be minus t. We take the second derivative is itself, and then this turns into positive. So now we take the left hand side, you plug them here. So you need the second derivative minus 4 times this, minus 4 times y. That would be minus 4a and minus 4b. This eventually should match the right hand side. Of e to the t, e to the minus t. So now let's look at the coefficients. I start with et. Here, at has a and minus 4a. This should match the coefficient of at here, which is 1. Minus 3a equals 1. Then a is negative 1 over 3. So let's look at the coefficients of e to the minus t. Here we have b, and here we have minus 4b, And here we have 1 as well. Minus 3b equals 1. Then b is minus 1/3. So your yp is a is negative 1/3, b is negative 1/3. So the complete solution is usually the homogeneous plus the non-homogeneous. So your solution is C1e to the minus 2t, C2e to the positive 2t, minus 1/3 e to the t, 1/3 e to the minus t. So this is the answer for the second question, which was the easiest of all three questions. I'll do the second question, which has a little bit of a different idea. So here, y double prime 4y equaling sine of 2t. So we start with the homogeneous solution first. You know this is m squared plus 4 equals 0. M squared equals minus 4. And the square root of this would be plus or minus 2i. So we know that it's 0 plus or minus 2i. So your real is 0. Your imaginary is 2. So the solution here for the homogeneous would be a constant e to whatever the real is, sine imaginary. We usually start with cosine, doesn't matter. And C2e real cosine imaginary t. So your solution for the homogeneous would be C1 sine, C2 sine, cosine. Because you know e to the 0 is 1. So now we go and do the non-homogeneous. Yp. When it's sine, you say, well, I can make this a sine of 2t, b cosine of 2t. This is my assumption for yp and work with it. But the problem is sine 2t is already repeated in the solution here. So I know already that sine t is already there. So that doesn't work. In this case, we need to do what's called upgrade family. So we need to do upgrade family. Since the sine 2t is already there, how do we upgrade? We add a t. So we go, it's a t of, it's like a sine 2t b cosine 2t. We add a t to the family because the normal one already exists. So that would be your up in this case. So now you take the derivative. We apply product rule here. Derivative of t is 1, so you're left with sine of 2t b cosine of 2t plus, you take the derivative of this times t, which is 2a cosine 2t, 2b sine 2t, all of this times t. If you want to write it so that it looks a little bit better, it's a sine 2t, b cosine 2t. Now take the t inside, 2a t cosine 2t, and times this would be minus 2bt sine of 2t. This is the first derivative. But in order to solve for this, we need the second derivative. For the first one, it's 2a cosine 2t. For this one, minus 2b sine 2t. Here we do the product between this and this. Derivative of 2at is 2a times cosine 2t. Derivative of the second one would be minus sine, so minus sine of 2t times 2 times 2at would be 4at. We do the product between negative 2bt and sine t. Derivative of minus 2bt is minus 2b sine of 2t. Derivative of sine is cosine times 2, and we have the first function will be 4bt. If you want to combine this and make it look a little bit better, you have 2a cosine, 2a cosine, so that adds up to 4a cosine 2t, minus 2b sine, and minus 2b sine, so that's minus 4b sine of 2t. And we have this one, which is minus 4at sine 2t. And we have this one, which is 2b. You have this one also, which is minus 4bt cosine of 2t. Okay, now once you did the second derivative, you're ready to do the left-hand side, which is take the double prime plus 4y. So this and 4 of this. So if you take this and 4 of this, now this actually is at sine times 4 would be 4at sine. And 4at sine with minus 4at sine, they cancel each other. And 4b and the 4b here, cosine, they also cancel. So these two terms would cancel each other. You're only going to left when you do this with 4a cosine and minus 4b sine. That's left, which should match right, which is sine of 2t. So comparing coefficients for the sine 2t, you have minus 4b and 1, making b minus 1 over 4. And comparing cosine of 2t coefficients, here we have 4a. Here we don't have cosine, so a is 0. That means that your UP is cosine A is 0, so that cancels out. And B is minus 4, so your answer would be minus 4 t cosine of 2t. Y is YH plus YP, so you add the homogeneous to the non-homogeneous. So eventually the answer would be C1 sine 2t, C2 cosine 2t, minus 4 or 1 over 4 t cosine of 2t. That's your final solution in this case. Good? So it was a little bit different than the first one. I'll do another question so that you can appreciate the idea a little bit. This question, y double prime, y prime, 9y, t squared, 2, 12, 3t. So we'll do the homogeneous first. So we have m minus 3 squared. So the answer is m3, and we know it's repeated. When the answer is repeated, the homogeneous would look like this: C1 plus C2t e, answer t. So your homogeneous in this case would be C1e to the 3t, C2te to the 3t. This here is your homogeneous. Now you take the UP, but there are two sections here. There is the polynomial first. The highest power is t squared, so you go, it's at squared bt plus c, that's for the polynomial. Now we go to the exponential. The exponential is e to the 3t, and we have e to the 3t. So if you have this, you have to upgrade family. And you see here, e constant already there, et is already there, so the upgrade in this case would be t squared. So you always go one higher than what you have. So when you have something, you go one higher. So in the previous question, we had the sine 2t, so we went one higher, so we added a t only. Here, we have the e, but we have the constant and the t, so we added one more. So now we need the first derivative, 2at b, product rule here, 2dt e3t, and 3dt squared 3t. We also do the second derivative, that's 2a. Here again, product rule, 2de 6dt e3t. Here, product rule, 6dt e 9dt squared e3t. So, if you want to make it look a little bit better, it's 2a 2d e3t. I can combine these two together and make them 12dt e3t. And this one is 9dt squared e3t. So we put them all on the left hand side. We need this minus 6 of this plus 9 of this. So you need 2a 2d e3t. You need 12dt e3t. You need 9dt squared e3t minus 6 of this, so minus 12at minus 6b minus 12dt e3t minus 18dt squared e3t plus 9 of this plus 9at squared plus 9bt plus 9c plus 9dt squared e3t. Now let's try and simplify this. Now, numbers by themselves, we have 2a, 6b, and 9c. Those are the numbers that are by themselves. Something t, we have 12a, and so we have 12at and 9bt. That's the just something t. So we did the something t, we did the number. Let's see t squared, that's the only one t squared, that's 9at squared. Let's look at the ones involving something e3t with no t or t squared. So we have this, that's the only one. So 2d e3t. Something with t, te is this one, which would cancel with this one, they minus each other. So they're all gone. And this and this and this, they cancel each other, they're all gone. So that means that this is the simplified version of your UP, which must match 6t squared to 12e3t. Okay, pure number. So we go to coefficients. Let's look at pure number. Pure number, 2a, 6b, 9c, and the pure number here is 2. Let's look at the t. Here, minus 12a, 9b, here nothing. Let's look at the t squared. We have 9a here and 6 here. That means we can solve for a. 6 over 9, which is 2 over 3. Once you know a, you put it here, you can solve for b. So minus 12 times a plus 9b must equal 0. So this and this has minus 8 to bring it over. So 9b is 8. That means b is 8 over 9. So once you have b and a, I can use this to solve for c. So 2 of a, 6 of b, 9 of c must equal 2. So this is 4 over 3. This is 3 and 3. So that's 24 over 3. 9c equals 2. I'll continue in the next page here. So that's negative 20 over 3, bring it over, so 9c equals 2 plus 20 over 3. So 6 over 3 plus 20 over 3, so 26 over 3. So 9c, 26 over 3, so c would be 26. You put the 9 down, 9 times 3 is 27. So I know my A, my B, and my C. A is 2 over 3, B is 8 over 9, and C is 26 over 27. We still have the D, so we keep comparing coefficients. The only thing left in comparing coefficients is the 2D. And that would be for the coefficient of the E3T. Here you have 2D, and here you have minus 12, so D would be negative 6, so now I know all of them. My UP now, A, which is 2/3 of T squared, B, which is 8 over 9, C, which is 26 over 27, and D, which is 6 T squared E3T. This is your UP, this is your UH, Y is you add them. So C E3T, C2E3T, plus 2/3 T squared, 8 over 9T, 26 over 27, 6T squared E3T. This is your final solution in this case. Now I'll go to the first question in your homework, and I'll show you why it was a bad question. It was double prime 9y equaling 2t t squared t5 et 7t squared e minus 3t and t sine t. So we do the easy one that pretty much everybody did, the homogeneous. So that's 3 squared equals 0. It's negative 3 repeated. In this case, your answer would be C1 plus C2 TE to the minus 3t. So your homogeneous would be C1E negative 3t and C2 TE minus 3t. That's your homogeneous. YP. So I start with the polynomial. So you have to be a t squared bt and C. Here we have a polynomial e to the t, and we have e to the minus 3t, so that's different. But because it's polynomial to the degree 5, you have to go from degree 5 to nothing. So d t to the 5, e t to the 4, f t to the 3, g t to the squared, h t and I, all of this to the e to the t. Here we have a repeated e to the minus 3t, but that's not a big deal because you have to upgrade family. I don't have this. I have only t this and a number this. So that's, I don't have. In this case, I don't need to upgrade family. All I need to do is a polynomial, so it would be I, so it would be j t squared e to the minus 3t. This one is similar. Remember the question when we had the sine 2t, and I told you when you have the sine 2t, your up would be this, but since you have it, we needed to upgrade. Here, it's t times sine, so polynomial times sine. In this case, you need kt plus I times sine t cosine t. And if you notice, I have my variables all the way to I. And when I find I need to find the derivative and to the second derivative. And finding the derivative will involve product rule here, product rule here. When it's time to find the second derivative, it gets really messy. So that's why I really don't know why he asked this question. I'd rather if he just asked to set up the question like this and not solve, would have been much better. So that's why, I mean, I tried finding derivative and the second derivative. It was too long, a lot of variables, and I kept missing a lot of them. That's why I didn't bother. So hopefully he does something like maybe make it worth, it was worth 3 points, I believe, and you will get something from doing the homogeneous part. But this is it for worksheet 5. And I'll see you again when it's time for the next one. Bye.